Corporate finance practice problem in Excel. We're going to talk about the calculation of the rate that might be used on a bond, and then think about the changing of that rate having a different weight on the bond to the market rate and calculate the price of the bond in that circumstance. This is a second problem of a similar nature. Get ready. It's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we are in the practice tab as opposed to the example tab. The example tab in essence being an answer key. We're going to have the information on the left-hand side. We'll use that information to populate and work through the problem in the blue area on the right-hand side. Information includes the information that could be, we imagine, basically on the bond, which would be the par value 1,000. We're going to say the life is 24, meaning the expiration date or maturity date is going to be 25 or after 25 years. And then we'll calculate the rate on the bond. Now note that when we issue the bond, we're imagining at the point in time of issuance, we're trying to come up with a rate that is the market rate, thereby having the amount on the bond, the rate on the bond, and the market rate the same, so that we could actually sell them at the face amount or par value of the 1,000. Then over time, of course, or if circumstances change, the rate on the bond will differ. So one way we might consider and think about the rate on the bond is calculate some factors that would be involved, including the rate of return, the inflation premium, and the risk premium might be some things that we take into consideration, in this case getting to 16%. Now we're actually going to then calculate this as if the rate on the bond and the market rate are the same as it would be, or we would expect or hope it would be at the point in time the bond is originally issued or first issued. Then at a later point in time, we will calculate after 10 years the risk premium going down, which means that the market rate is going to now be different than the rate on the bond, because the rate on the bond will not change, whereas the market rate will change. This first one, when we calculate it, you might say, well, why would you do that? You're just going to come up to the 1,000. True, but it's a little bit confusing just to see that, because we're still going to present value these payments at the 16% for both the market rate and the rate on the bond, and it's still a little confusing because we have to still do these present value calculations. So I just want to show that you'll get to the 1,000 if you do it with the 16% for the both rates, and then we will adjust it and see what the impact is on the price. So we'll start off with the 1,000 here, and that's going to be a par value. We have two things going on: the annuity of the bond, the present value of the 1,000 as well. We got to add those together to come up with the price. We're going to first get the price, which at the end of the day will equal that 1,000, but we'll do it in this format. So we're going to start off with our annuity formula, P times 1 minus 1 plus R to the negative N over R. Going to break that out into our table as we have seen in the past. We're going to pick up the 1,000 times the 16%, which we're saying is the amount on the bond and the market rate. That would be 160 for 25 years, these being annual payments. Then we're looking at the 1 minus 1 plus R plus N, 1 plus R to the N. 1, I'm going to bring in the inner column. Then we'll do the 1 plus R in here. 1, R being the 16% again, that now being the market rate, same rate. Home tab numbers, percentifying it. Home tab font, underline it. Then equals the SUM, summing up those two amounts. We need to make this a percent, number group, percentify to the negative N number of periods, 25 in our case. Going to underline that, home tab font, underline, pulling that out to the outer column, this now being the 116 shift 6 caret to the power of negative 25. We need some decimals here, number group, decimalizing it, and then home tab font, underline. Now we're going to take the 1 minus what we just got to get to the num or numerator. 1 minus that number, there's the num, but we want some number group, more decimals to give us some more detail. That's the num or numerator. The denom or denominator being the 16%, this being the market rate, same as the rate on the bond. We're going to say then home tab numbers, percentify, underline, home tab font, underline. We have the num and the denom. Now we're going to take the num and divide by the denom. There's the numerator divided by the denominator. Adding some decimals, home tab, numbers, decimals, added, underline, home tab, font, underline. Then we can multiply out the outer column, that being P times that amount that we just came to. Add a couple pennies, number group, pennies added, 53 of them. So there's the present value of the annuity. We need to add that to the present value of the 1,000. First, however, let's calculate this one a few different ways. Let's do it with our formula over here first. Doing the formula, the easiest way to do this, negative present value, shift 9. Rate is going to be that 16%, comma. Number of periods now is going to be 25. There's 25 of them. Periods, that is. And then we're taking the payment, which is going to be 160, 160, and there's the 975.53 again. Now let's break our annuity payment into 25 payments, present value of 1 payments, and we'll get to the same number, and then we'll tack on the 1,000 to get to our price that way, because that'll be good time. So we got 1, 2, and then we're going to use the autofill handle, autofill, selecting these two, grabbing Phil's handle, dragging Phil's handle down till we get to 20, and then it autofills. Autofill, home tab, align, and center. Payments then are going to be that 160 for this entire time. It's an annuity, but we're going to treat it as 25 present value of 1s and do our present value calculations, which will be negative present value, shift 9, rate 16%, comma, number of periods 1, because this is just 1 period out, the first payment. Future value, not the payment, because this is present value of 1, 138. That's going to be our value. If we do that again, the payments will remain the same, because that's what it means to be an annuity. That's what annuity means. Payments same over multiple periods. Present value, shift 9, rate 16, comma, number of periods 2, comma, comma, because it's a present value of 1, not an annuity, 160. There we have it. If we add up the prior one plus the current payment, there's where we stand after the second period. Let's go ahead and autofill this down, but as we do, we want to make sure that anything outside the table that's in our formula, that's 16, needs to be an absolute reference. We're going to do that by double-clicking the present value, putting our cursor in E6, selecting F4 on the keyboard, $ before E and 6, therefore absolutizing it, making it an absolute reference. Enter, selecting then these 3 tabs, grabbing Phil's handle for the autofill, dragging Phil's handle down to 25 times for the autofill. There's the 976 rounded. There's the 975.53. We could do this one more time and say, why don't I do this one more time for that present value of the 1,000? And that'll give us our answer. So let's do that. Let's fill this down one more time. Still at 25 periods, because this is that last period, but this number, not 160, not an annuity kind of payment here, but rather present value of 1 for that 1,000, the par value of the bond. And if we bring that back, we get to the 24 payments, and that brings us to 1,000, which we would expect, because the value of the annuity had the same rate on it as the market rate, which is kind of proving that. We will get to that again. Let's continue this again just to prove this or see it a few different ways. Let's do this with the table. We want to get to this number again, the annuity portion. Table is going to be the 160, and then we'll look this up on the table, making sure we have the proper table, annuity table, present value, 16%, 25 payments. 16, 25. There's the 16, looking for the 25. There's the 25, that's going to be the 6.0971. 6.0971, 6.0971, 6.0971, 6.097. That's not 71. And then we'll take the 160 times the 6.0971. We get the 975.54, slightly different, off by a penny, different by a penny due to the table's rounding. Now we got a present value, then the 1,000 that would be there after the end of the bond, in this case 25 years, 25 periods, annual bond. Let's present value this using our formula down here. PV equals the future value over 1 plus R to the N. Putting that in our table format. We got the 1,000 here. Then we're going to pull the 1 plus R to the N. On the inside, there's going to be 1 R. Then 16%. That's both the market rate. We're thinking of it as the market rate here, but it's the same as the rate on the bond in this first part. Home tab, numbers, percentify, underline in the font group, summing up using the trusty sum function, the favorite function of all Excel users. Home tab, numbers, percentify, and then we're going to take this to the power of 25, the number of periods, the power of 25. Home tab font, underline, pulling this to the outside. This is going to be 116%, shift 6, caret, in other words, to the 25 periods. Adding some decimals in the numbers group. Decimals added, underline in the font group. And then we'll go ahead and do our num, the num divided by the denom. The num divided by the denom, adding a couple cents, making some sense out of it. 47 cents has been made out of it. And then if we take that and add it to what we got from the annuity table over here, there's the annuity table. We have the two components added together now, and we get the result 1,000, just like we suspected it should be, because the market rate is the same. But it's not as clear as you would think, right? We're still doing these present value type of things. It's still a little confusing. Then we'll change this up next time. But let's calculate this one a few different ways now. We're going to say, let's do it with the formula, the magic way. Let's let the magic happen. Present value rate. That's why we're in Excel in the first place. The rate's going to be then this 16%, comma, and then the number of periods is going to be 25, comma, comma, future value 1,000. There's the 2447 again. One more time with the tables this time. Table time. Making sure we got the proper table that's being present value of 1. We're looking 1625. 1625. There's the 16. There's the 25 right there. That's the 0.0245. 0.0245, 0.0245, 0.0245, 0.0245. And then we're going to take the 1,000 times the 0.0245. Gives us the 2450, slightly different than the 2447 due to rounding, tables rounding 4 digits. Okay, so our answer was the 1,000 as suspected. Now, going back to the left-hand side, let's make a change. We're going to go down, scroll down here. This time I'm in column A, and we're down here now on like row 76. And now we're going to say, now time has passed. It's just like a movie where they're like, and time has now passed. After 10 years later, then the risk premium has changed to 3%. So the risk premium was 7%, and now it's 3%, and time has passed, which includes 10 years have passed. So now we got the life was 25 minus the 10. We're looking 15 years out at this point. Okay, so let's calculate the price then now, given the difference that has taken place. Same kind of thing. We're going to start off with basically the present value of the annuity formula, P times 1 minus 1 plus R to the negative N over R. Breaking that out in our table, this is going to be P, which is going to be the 1,000 times the rate on the bond. It hasn't changed. It's still 16%, no change. But the other rate has, and we'll get there shortly. Then we're going to pick up 1, and then this inner column, this is going to be 1 plus R to the negative N. 1. R, this is where the change happens. This is where the change happens. It was 16, but then minus, I'm going to say shift, put the brackets here. It's going to be this one, the risk one, went down to that. So that's going to give us, if I percentify that, it's 12. In other words, you could think about it this way. So 5 plus the 4 plus the 3, and that's going to give us the 12. But I want to do that with formulas here, so I kind of formalized it. One formula you could do is just the 5 plus the 4 plus the 3, so that we're referencing to the table, which is just standard good practice with Excel, instead of hard coding the number over here, because then you can't like change things as easily and whatnot. So if we go to the Home tab, Font Group, and Underline, let's sum this up, equals the sum of these two, percenting that, numbers group, percent. And note, unless I say it's not in the Home tab, assuming Home tab, we'll just go right to the groups here up top. And then we're taking this to the number of years now, which was 25, but then 10 years have passed, so minus 10. I'm saying negative plus 10 because I want it to be a negative number, negative 15, in other words, 25 minus 10, but then it needs to be a negative because that's what our formula says. So 15, negative 15 in essence. home tab, font, underline. I don't need to say home tab anymore because we discussed that. We're in home tab by default. Anyways, this is gonna be the 112 shift 6 caret 15 or negative 15, adding decibels, numbers, decimalize, font group, underline, subtracting out to get to the num, 1 minus that decimalized number, adding decimals, numbers, decimalize, there's the num, there's the numerator. Bringing in the denom, which is going to be the rate, which is that 12% again. I won't calculate it again. I'll just put the 12%, but you know it's this, that, and this. That's the 12%. And then we'll percentify that, number group, percentify, underline, font group, underline. Then we'll take the num over the denom, the num divided by the denom, adding some decimals in the number group, adding some decimals, throwing an underline in from the font, underline, multiplying out the outer column, the 160 times that thing we just got, adding cents. Cents needs to be added. Number group, cents, 74 cents. Let's do this again. Let's do it first with the formula. That's going to be over here. So this is the fastest and the magical way of doing it. So this is going to be negative present value, shift 9, rate. I'm going to pick up the 12% right here this time, comma, number of periods now is going to be, we said 25 before, minus 10 because time had passed. And then the payment is going to be 160. That then, once again, is the 1,089.74. Now let's break this down into our annuity table, one at a time. The 20 or 15 payments now broken out into 15 payments of 1 instead of an annuity. So we'll take 1, 2. We're going to select those 2, grab Phil's handle for the autofill, take Phil's handle and drag it on down to 15 periods, and then go to the home tab, alignment center, and that has been auto-filled now. We're going to say the payment's going to be 160 per payment. There's going to be 15 of them in our annuity. We're going to then present value them just one at a time. Negative PV, shift 9, rate 12% is the rate, comma. Number of periods now 1, because this is just one payment out, comma, comma, because it's not an annuity. Future value, 160, and enter. That's the present value of the first one. Let's do the second one. Payment's the same because it's an annuity, and that's what annuity means. That's what it means to be an annuity. That's what it means. So we're going to say 12, comma, number of periods 2, comma, comma, future value 160. And now we're at the last 143 plus the 128. I want to copy this down, but before I do, I got to make an absolute reference of anything referred to, typically outside the table we're in the data group. That 12%, in other words, double-clicking the present value, that 12% is in cell E79, putting my cursor in E79, selecting F4 on the keyboard, $ before the E and 79, enter. You only need a mixed reference, by the way, for picky people, but absolute will work too. We'll select those 3, we'll put our cursor on the fill handle for autofill and drag the handle down. Don't let go of the handle until you're down to 15 periods, then let go, and autofill does what autofill does. It fills the thing automatically. So we got the 1,089 about the 1,090. We could do that one more time here and get to our answer. So let's do that. Grab that fill handle and drag it down one more time. But we need 15 payments, doubling up on the 15, changing the 160 then to the 1,000. That's going to be the amount of the end payment of the principal, and then that means that that part is going to be about 183, giving us the total of 1,272. That then would be basically the answer of the value after this change took place. Notice it's higher than the value here, the 1,000. Why? Because the risk premium went down. So that means that the market rate now is less than the rate on the bond. And if we're the one issuing the bond, if you think of that perspective of it, we would be saying, hey, look, you're not going to get another bond that's going to be paying you 16%, because other bonds out there, due to the risk premium going down of a similar nature, are going to be paying less than that. So we're going to sell you the bond at a price higher than the face amount of the bond, because of that. So that's going to be the concept, but we'll get to that number again. Let's make it yellow here because that's a little bit different part of the annuity table. Here's the end result of the annuity. Let's go ahead and do that with the table time now. Table time is going to be the 160. Looking up then the amount on the table, we're looking for the 12% on the annuity table, and the number of periods is going to be 15, 10 to 25 minus 10. So 12 and 15, that's what we're looking for. 12 and then 15. 6.8109, 6.8109, 6.8109, 6.8109, 6.8109. Then we'll take the 160 times the 6.8109 and we get that 1089.74. So same number here. Now we will calculate the present value of the 1000 at the new rate that with this change that took place using the present value of 1 formula. Present value equals future value over or times 1 over or 1 plus r. So let's do that in our little table here. We're going to say we have the 1000 now. Present value in that, 25 minus 10, or 15 periods. 1 plus r to the n. So we're going to say 1 rate r. Rate is, I would do it this way this time. It's that 5% plus the 4%, but then this one changed to 3%. And then if I percentify that in the number group, 12%. Font group, underline. Summing up with the trusty sum equals sum. Shift 9. Those two. Numbers group, decimalizing or percentifying it. And then to the number of periods, which is going to be 25, but then time passed, 10 years, minus 10, 15 periods remain. And then we're going to go to font group, underline. And then we'll take the 112%, shift 6, caret 15, enter, adding decimals from the number group. Decimals added, font group, underline applied. Then we're going to take the num divided by the denom. The num over the denom. And then we'll take the numbers and add some cents, 70 cents to be exact. And then we'll take that and then add what we got to the annuity in our last portion over here. On the annuity side of things, we were at the 1089.74. So if we then take this 182.70 plus that number, we get to our end result, the 1272.43, which should match what we got over here, 1272 about, right, because it's rounded there. And that then, once again, is the price that we would come to at the end of the day. And notice it's higher than the 1000 because now the market rate is less than the rate on the bond. So when we sell the bond, we're going to be like, we're going out there like confident. We're saying no one's got a bond out there as good as our bond that they can get 16% on. So we're not going to sell it for 1,000. We're going to sell it for 1,272.43 out there. And that's so it's higher because we sell it at a premium. So then we can do this again. We're going to calculate this one a couple different ways as we close things out here. The next way, the magic way, Excel way, present value, shift 9, rate 12%, comma, number of periods 15, comma, comma. And then, because it's not an annuity, future value 1,000. There it is again. We did it again in a different way. And then we'll pick up this 1,000 again, this time with the tables, making sure we got the right tables. Present value of 1, not an annuity. We're looking 12%, 15 periods. There's the 12 on the percent side of things. There's the 15 on the period side of things. We're looking 0.1274. 0.1827. 0.1827, 0.1827, 0.1827, 0.1827, and then we'll take the 1,000 times the 0.1827. We get the 182.70 again.